Okay, now let us consider how to form the equations below here. Yeah? How to form all these equations. Okay, first of all, I need to just remove all these. Yeah, remove all these. Yeah. Okay, so what I can say is what I can say is just now you learn about the first particle light cancel with the first particle light from both parts, and then the second particle, so they always pair up. You see that? They always pair up. The first particle pair up with the first particle here. The second particle always pair up with the second particle here. They always, what I can say, they always pair up. They always pair up to they pair up to cancel. That's all. That's it. Yeah. We can say you need two particles. Each of them, they need two particles wave. They need two particles waves. They need two particles waves to pair up to cancel each other. Okay, from each part. The first particle pair with the first particle, second particle pair with the second particle, third particle pair with the third particle wave. Okay, to cancel each other. Ultimately, all the wave in part 1 being cancelled by all the wave in part 2, because each pair their delta L is each pair of wave, the delta L is half lambda for in-phase source. Yeah, for in-phase source. That's why they can cancel each other to produce dark fringe when it is delta L is half lambda. Okay. Now, okay, enough for that. Now let's look at how to form the formulas. Okay, sorry, again, yeah, how to form the formula actually. Yeah, for this, let me remove all this first. All right, now let's look at this one. Yeah, the first one, the even pair. Yeah? The even pair, which is a 2 pair. I divide into a divided by 2. Yeah, so each size is a over 2. So now you see here, so a and c, the delta A is half lambda. Yeah, the delta A is half lambda. So I can draw. Maybe I can draw over here. So half lambda means, you know, 1 lambda is how big? One lambda is like that. Yeah, 1 lambda is like that, isn't it? If half lambda is you can just see half of it lah. You can see just half of it lah. This is half lambda lah. Okay, 1 lambda is like that. Okay, so you see like from A to between A and C, the difference is half lambda, isn't it? So I can draw like that. This is half lambda. Half lambda. So half lambda. So the delta L, we can say the delta L, CE. You know, you can see the CE is the delta L. CE is the delta L. Delta L, which is only CE is only delta half lambda. Okay, so CE is delta L, which is half lambda only lah. Okay, so I can write like that. See that? So the delta L, which is actually the CE, okay, which is the CE, okay, CE. The delta L is we can say how to find this this value. You know, this is A over 2 sine theta. Why? How to get the A over 2 sine theta? Actually, this one is like the double slit. Yeah. If you can see here, there is a small triangle, isn't it? Small triangle. And you can see here you have theta 1. You have theta 1. Okay. Look at here. This small triangle is actually related to the double slit. Related to this double slit. You know, this small triangle and the big triangle, so it come back to the same thing for single slit. You can check back the double slit. Yeah, so for the small triangle here, you can see the small triangle here Okay, this is the theta, isn't it? Theta 1, right? Theta 1 is over here. So this is I can say this is the ACE. Okay, so this part is the delta L. Yeah, so between C and E, this is the delta L. Okay, and what is AC? AC is A over 2. AC is A over 2. That's the hypotenuse. And this is the right angle. It's right angle over here. Isn't it? It's right angle over here. So this is theta. This is the hypotenuse A over 2, and this is delta L. So how to find the delta L? So we can use this is hypotenuse. Okay, let's do it out. So we can know the sine theta 1 is equal to opposite over hypotenuse, isn't it? What is the opposite? Opposite is the delta L over A over 2. Over A over 2. Okay, this is A over 2. So now you can see what is the delta L. So the delta L. So from here we can see A over 2 just go to the top. Yeah, multiply to the top, and what do we have? What's the delta L? So the delta L is A over 2 sine theta 1. Okay. So now do you know that why delta L equal to A over why the delta L, CE is the delta L, CE is the delta L, why the CE is A over 2 sine theta 1, why the delta L is A over 2 sine theta 1? Because of this. A delta L is, use the trigonometry only, trigonometry, delta L is A over 2 sine theta 1. Okay, so now we have it. Okay, so delta L is A over 2 sine theta 1, and it is half lambda. It is half lambda to produce the dark fringe. Okay, it is half lambda. Yeah, CE is half lambda. So now these two can cancel each other. Okay, and in the end we get A sine theta 1 equal to lambda. A sine theta 1 equal to lambda. Actually, you can see what is this A sine theta equal to lambda? Actually, A is the whole slit, isn't it? A is the whole slit. If you look carefully, A with C, the difference is half lambda. C with B is also another half lambda. C with B is also another half lambda. Here you can see another small triangle. Here is another half lambda. So if we drag this down, directly downward, so here is already half lambda, CE is already half lambda, and then C to B here also another half lambda. So combine until here is 1 lambda. Can you see that? Here 1 lambda. So you see this one, this is the A. Okay, this is the A, this is the theta 1, and this one is 1 lambda. Yeah, between here to here, this is 1 lambda. Yeah, here to here is A. Here to here is 1 lambda. Here to here is A. So this is the theta 1. Can you see the theta 1? Can you see where is the theta 1? This is the theta 1. This is the theta 1. So that's why I can say theta A sine theta 1 equal to 1 lambda, equal to this equation 1 lambda, 1 lambda, 1 lambda here, yeah. A sine theta equal to 1 lambda, 1 lambda. And then this one, you can see a big triangle here. Can you see a big triangle here? This big triangle is just like the double slit. Here there is another big triangle. Here's another, sorry. Yeah, here's another big triangle. Big triangle. Here. This is also another right angle triangle. Right angle triangle. So this one will relate to yn and d, and here also another theta 1. Here also another theta 1. You see that? Theta 1 is here. So it's the same thing like the big triangle and the small triangle. Same thing like this single slit is the same as the double slit. See? The big triangle and the small triangle. The big triangle and the small triangle. This is the small triangle. See that? This is the small triangle, and this is the big triangle. The same thing like the double slit. If you investigate, you see the big triangle and the small triangle is the same thing. Yeah, small triangle and the big triangle. So the equation is actually using the same concept. Using the same concept. That's why the equation also become the same. The big triangle and the small triangle. This one single slit also use the what? The big triangle and the small triangle concept. So the small triangle is actually a and 1 lambda theta 1. So that's why it is this one is a sine theta 1 equal to 1 lambda. So this one, the order is 1. Actually this is n lambda. So n equal to 1. You got the first dark fringe. This is the, we can say we get here, we got the first dark fringe, and the order is equal to 1. That's why it follow the order. See that? This one, the dark fringe, it follow the order. It follow the order. Okay. So and then next, let's look at next one. Next one. Okay, if I divide into 4 parts, then we can say a divided by 4, so each size is a over 4. The same concept. The first particle cancel with first particle. Okay, so I can say the first particle here and the first particle here. First particle here and the first particle here. I can say the path difference is also delta L. Okay, I can maybe can draw like that. Okay, now this one also half lambda. Understand? Half lambda. I can draw like that. I can draw like that. Then it will be clear already. So all along here has many particles. Okay, you know. So the first particle here, the first particle here, and the first particle here also difference by half lambda. And then that's why following also talking about the okay, you see the first particle here and the first particle here also half lambda. Also half lambda. So the second particle here and the second particle here also half lambda. The third particle and the third particle here in these 2 parts also half lambda. So what I can say, the first part is being cancelled by the second part. Second part. So I can say this is part 1, part 2, part 3, part 4. So part 1 cancel part 2. Part 3 cancel part 4. Cancel part 4. That's why first part and second part they cancel. So no more light, produce dark fringe. And then the third part also being cancelled by the third part, by the fourth part. Third part cancelled by the fourth part, also no more light. So no more light. So in the end, this one even parts they also produce dark fringe again. Understand? Same thing like the sixth part also. Okay, don't talk about the sixth part yet. Let's look at this one first. Cancel each other. So before we talk about that, let's investigate about the. I just want to talk about the here. Okay. Now I just want to talk the half lambda. So you know why they cancel? You know why the cancel? Because each of them, the first particle here and the first particle here also half lambda. Also half lambda. Then we draw it down. We draw it down like okay, I draw it down like that. Okay, draw it down like that. The first particle and the first particle here half lambda. And then this first particle and the first particle here also half lambda. And then the first particle and the first particle here also half lambda. And the first particle and the last particle here also half lambda. That's why you can see here difference is half lambda. And then the following become 1 lambda combined. And then half plus half plus half become one half. And then the last one is half plus half plus half plus half become 2 lambda. Do you see that? So the first particle and the last particle difference is 1 plus 1 lambda. So 2 lambda. The first particle and the last particle here is 2 lambda. That's why become A sin theta equal to 2 lambda. Okay. So look at here. Yeah. So so this one, okay, we start from the beginning here, the 4 parts. So this size is 804, and then the theta 2, this one is the theta 2, yeah, it just not draw there. Here is the theta 2, okay, here's the theta 2, okay, so this is the theta 2, A over 4 sin theta 2 is lambda over 2. Lambda over 2 is the part here. Here is the lambda over 2. Yeah, first particle and first particle here also lambda over 2. That's why they cancel each other. Destructive interference, dark fringe. Okay, lambda over 2. So if simplify the equations, these 2 cancel. This one become 2. 2 multiplied above, we have A sin theta 2 equal to 2 lambda. This one exactly means what? The whole length, the whole width A, the difference, the whole width A, you have the path difference of 2 lambda. Here is 2 lambda. 2 lambda, you see? Because it's half plus half plus half plus half. 4 half. Yeah? 1, 2, 3, 4. 4 half. 4 half become 2 lambda lah. Yeah, 4 times half is 2. 2 lambda. Okay. So the small triangle here is 2 lambda. So A sin theta equal to 2 lambda. So here we can see the n again is 2. N is 2. This is the second dark fringe. Why we say this is the second dark fringe and why we say this is the first dark fringe? Why are you so confirmed? Because you see this one is we can say here the delta L between A and B, this one is just 1 lambda. You see that? Now I'm not comparing between A and C, I'm comparing between A and B, the first particle and the last particle of the slit. The delta L is 1 lambda. The delta L is 1 lambda. Delta L is 1 lambda. But this one, yeah, I'm comparing the, let's say the particle A is over here, particle A is over here, particle B is over here. What's the delta L between particle A and B over here? Yeah, the delta L is 2 lambda. Do you see that? For the first particle and for the first with 2 parts one, the delta L is 1 lambda. For this is for the 2 parts. This is for the two parts. For the 2 parts, the delta L is 1 lambda. For the 4 parts, the delta L is 2 lambda. So this one, of course, the bigger the delta L, this one 1 lambda only delta L. This one delta L is 2 lambda. That means when the big delta L is longer, means it's further up the screen. It's further up the screen. That's why this one is the this delta L is only 1 lambda. That's why it formed the first dark fringe. This one delta L is 2 lambda. It formed fringe at the further up the screen, which is the second dark fringe. second dark fringe. Okay? So as you divide into more parts, 2 to 4 to 6 parts, actually you're moving up the screen. You're moving up the screen because you divide into more parts means higher delta L. Higher delta L. You compare the first particle and the last particle. Let's investigate the 6 parts. Okay, let's investigate the 6 parts. Also the same. You see, the first particle and the first particle here, the difference is half lambda. Okay, maybe I should draw the line here. Draw the line here, and you can see clearly. You can see clearly. The first particle and the first particle here, difference is half lambda. The first particle and first particle half lambda, half lambda, half lambda, half lambda, half lambda. So total up, this one become 1 lambda, and this one 1/2. This one become 2, and then this one become 1, 2, 3 half, and this one become 1, 2, 3 lambda. See that? Half lambda, 1 lambda, 1/2 lambda, 2 lambda, 2/2 lambda. This one is 3 lambda. 1, 2, 3. 3 lambda. Total of 3 lambda. So this delta L now is 3 lambda. This delta L now is 3 lambda. Between the first particle and the last particle, the delta L is 3 lambda. For the A is 3 lambda. For A over 6 is only half lambda. Okay, A over 6 is only half lambda. But for the whole length, the first particle and the last particle is 3 lambda. So this is much higher up the screen. Much higher up the screen. The bigger the delta L means the bigger the the bigger the delta L, the higher the order, N or M, the higher the order. Yeah, it's we already learned about this. In phase and anti-phase. Remember what we learned before? Yeah, you see that? You see that? You see about this? The bigger, you see? The bigger the delta L, the higher the order. You see that or not? The bigger the delta L, the bigger the order. See, the higher. So in a nutshell, I can say, yeah. So the bigger the delta L, the bigger the order. Okay. So now let's go back. Yeah, let's go back to this one. I think I explained everything already. Delta L. So what I can say is dark fringe is how is as long as it is divided into even parts, then you will produce dark fringe. Dark fringe, because what I can say is the first part cancelled by second part, and then that's why produce dark fringe. This one also first part cancelled by second part, and then the third part cancelled by fourth part. That's why produce dark fringe. And this one also, the sixth one also, first part cancelled by second part, the third part cancelled by fourth part, and then the fifth one cancelled by sixth. Yeah, it's always the first cancel the second, the third cancel the fourth, the fifth cancel the sixth. That's why if even parts, because they even has a even pair, isn't it? So you have 6 pair. If you have 6 strip, means you have 3 pairs. Cancel totally. Yeah? All these cancel totally. For the odd parts, it will produce bright fringe. Why? I just tell you in the briefly. You know why for the bright fringe for single slit become dimmer and dimmer intensity? Because also same thing, also actually differ by half lambda. All differ by half lambda. So the first part cancelled by the second part. So it just left with the third part to form the bright fringe. This one also, the first part cancelled by second part, the third part cancelled by the fourth part, left with the fifth part to form the bright fringe. Where with the fifth light, nothing to cancel it, no light to cancel it, so it formed the bright fringe. This one also, first part cancelled by second part, third part cancelled by fourth part, fifth part cancelled by sixth part, 7 7 part, it doesn't have a partner to cancel it. This one form the bright fringe. That's why the intensity become dimmer and dimmer. Yeah, because less and less light remaining. Yeah, because less and less light not cancelled. So that's why the intensity will decrease as it go up to the fringes. Yeah, that's why that explains why the central bright fringe is the brightest, because it only has one part. You know, it only has one part and no cancel at all, no cancel of light at all, no cancel of light. So that's why it's the brightest intensity. But the following up the first bright fringe, the intensity suddenly drops drastically, because it only left with only what I can say 1/3 of the light only. Only left with 1/3 of light. 1/3 of light. This one only has 1/3 of light left. 1/3 of light left. 1/3 of light left. This one only have 1/5 of light left. This one only have 1/7 of light left over, not left over. It's not being cancelled. That's why the intensity decreased so much. Okay. After that, we will explain about the odd parts again. Now, so for the equations, okay. So I already tell you it cancel each other, the light, because of half lambda. So as you can see, this is the dark fringe formula. This is the dark fringe formula. A sin theta equal to 1 lambda, A sin theta equal to 2 lambda, and then we have A sin theta equal to 3 lambda. So you can say 1 lambda, 2 lambda, 3 lambda. It is in the format of n lambda. A sin theta equal to n lambda. So remember about this, I relate between A sin theta and the yn. That's why I explained to you about this, the double slit. The double slit d sin theta to n lambda, the y also use n lambda. So double slit, remember, if d sin theta is using m lambda, the y also use m lambda. If d sin theta use m plus half lambda, the y also use m plus half lambda. So same thing goes to the single slit. Yeah, we also have the small triangle, big triangle like the double slit. So I didn't show you how to get these equations. To get this equation. To get this equation is much the same like the double slit derivation equation. So you no need to study the whole thing all over again. So for dark fringe, the formula is A sin theta equal to n lambda, and also because A sin theta is using n lambda, that's why the y is using n lambda also. N lambda d over A. All right. Okay, so and then the order, you see the order start from no zero order. The first dark fringe is the first order. It start from 1. That's why the order for single slit is start from 1. It's not start from 0. You cannot see 0 over here. There's no zero order. That's why I say no zero order for single slit. It's all because of the equations. It start from, what I press. So you see, you can see the order start from 1. It doesn't start from 0. It start from 1. Yeah, because the first dark fringe you investigate is n is not equal to 0, is n equal to 1. That's why the order of single slit is start from 1. Okay, so that's the dark fringe. Okay, the following videos I will explain about the bright fringe. Okay.